Assalamualaikum and hi everyone. We are Group 49. We will present a project that we have worked on in the semester of May 2021. But before that, let us introduce ourselves first.
Hello, my name is Bon Afwa Biman Zaki.
Hi, my name is Nurnida Nabila binti Hirman.
Hello, my name is Alif Fahmi bin Azhar.
Hi, I am Masdiana binti Muhammad Khalid.
And hi, my name is Muhammad Nur Adam bin Kamar Zaman.
First is the project background. The title is there to provide necessary friction force to help car to come to a full stop and drive by having a water flow system on the tire surface. However, tire tread worn out over time. Driver need to check the tire condition manually, which is inconvenient. Luckily, the tire tread ultrasonic sensor or TTUS can tell the depth of tire groove and detect abnormal tire wear. The sensor will inform the driver through a display in the car. The project aligns with the 9th SDG, which is the Industry, Innovation and Infrastructure. Next is the problem statement. Car crash is unavoidable, which causes the number of injury and even death spike each year. This is due to faulty tire that is exposed to threats such as potholes and foreign objects. One tire that caused the car to not able to grip the road surface is another cause that led to a car crash. Objectives of this project. First is to design a tire safety system that can give accurate and full information about tire condition using ultrasonic sensor technology. Secondly, to develop a program that is compatible with the car computer system, which converts raw distance data into an informative graphical display. And lastly, to make the calculation of operational procedure, cost, and choices of material and necessary measurement of the proposed design.
Worn tire treads are one of the common causes of vehicle tire failure. It is important for drivers to know the various tread patterns of tire. There are 4 categories of tire tread design, which are directional, non-directional, symmetric, and asymmetric. However, the depth of all types are the same, which is within the range of 7 mm to 9 mm. In order to prevent accidents due to tire defects, drivers should know when is the right time the tire should be replaced. That is when our project's idea comes up. In our project, we use an ultrasonic sensor that will help the drivers to monitor the tire's condition efficiently by calculating the tire tread depth. 2 distances will be used to calculate the depth, which are the distance between the device and outer tire surface and the distance between the device and the grooves of the tire. Here is the statistics on car accidents due to tire problems. According to Minister of Works, up to 10,000 cases of accidents in Malaysia in 2019 are caused by retreaded tires. The number of total accidents in that year is averaged out to be about 30% accidents daily due to burst retreaded tires. The graph shows the fatalities in crashes involving light passengers in vehicles with tire-related issues from 1992 through 2017. From 2007 to 2010, the average annual count of deaths was 565, while from the year 2011 to 2017, the average was 598. The average increases by 6%. For design thinking tools, there are 5 stages in total, which are empathize, define, ideate, prototype, and test. In empathize stage, we approach users to understand their needs and expectations of our product by conducting a survey through Google Form. In define stage, we gather all the findings from the survey and do some research related to our project. Then we analyze the information obtained to generate and develop solutions to the problem statements. Next, we simulate the ideas regarding the product and bring the conceptual idea to life by creating a product system interface. Lastly, in test stage, we seek some feedbacks from customers about our product through Google Form survey.
Now for the project planning and methodology part. At first, deliberation of ideas between members is done. Then, we came out with a draft design of our product. Research was also done on the material selection part. Moving on, finalization of our design is done and the following user interface is designed. Working principle of our product was simulated to detect the tire problem, and all the design concepts were evaluated by Dr. Wesam, which is our supervisor. Now for the task distribution, Adam leads the team and also leads on the product designing. As for the coding part and user interface were done by and lead by Diana and Afwa. Fahmi, which is myself, lead for the simulation video, and I'm also leading the research on article review. Our poster designing and survey handling were done by Nida. That's all from me, thank you.
For engineering analysis in our project, we use ultrasonic sensor to measure the depth of tire tread, microcontroller as the central of control and communication between all the components in the system. Arduino is used for the data processing system and the language used is C++. A wireless connection that will connect microcontroller to the user interface is serial Bluetooth module. And last but not least, accelerometer is used to measure the acceleration of a motion. The sensor will take measurement when a car moves less than 30 km per hour. The table shows the capital cost consideration of our product, which is tire tread ultrasonic sensor. Our total is around 400 ringgit, so the commercialized price will be around 5 to 600 ringgit. Some items like dash screen may not be included in the cost, as some vehicles already have a dash screen.
Now, we will continue with the design selection. The sketch that you are seeing right now is the top, side and front view of the sensor. The thickest point of the sensor is only 21 millimeters high. The width is 90 millimeters, and here in the picture, the length is 250 millimeters, but it will vary according to the type of the vehicle because different vehicles have different tire width. Let's continue with the overview of the tire tread ultrasonic sensor. First, the black cuboid is where the microcontroller is located. Other components like wireless module that sends the data to the display unit in the car's cabin also located here. This part also acts as the data interpreter where it translates the distance recorded into useful info about the tires to acknowledge the users. Next, the servo motor serves to move the protective glass to close the sensor when the sensor is not operating. The ultrasonic sensors are in an elongated row to ensure that the entire surface of the tire can be detected and monitored by the sensors. The casing is to protect the components from being exposed to the external environment that is at risk of damaging the sensor. Alright, now let us watch the demonstration design concept video of the tire tread ultrasonic sensor.
In 2007 to 2010, the average annual counts deaths related to tire defects in US are 565. In the following year from 2011 to 2017, the accidents related to tires defect increased 6%, 598 deaths. The sensor is located above the tire housing and it has the same length with the tire. Driver received the information of their tire through dash screen. When tire problem is detected, red warning error will pop up to indicate tire problem. Problem regarding tire can be detected. The working condition of the tire is determined based on the tire groove's depth. When user install new tire, the information on the tire tread will be stored. The difference between grooves distance from initial condition is compared to the current tire. When no tire problem is detected, dash screen will display the working condition in percentage. The higher the percentage, the better the working condition of the tire. When working condition is below than 6%, red colored tire will show. With 6% working condition, the car system will stop after 50 kilometers distance is covered. This measure is done to prevent accidents due to the condition of the tires that can no longer be worn. 50 kilometers distance is provided for drivers to find the nearest workshop. User then get their tire changed at a nearby workshop. After new tire installation, user then can continue to drive safely.
We conducted a survey through Google Form to generate feedbacks from customers about our product. Based on the results here, majority of them are satisfied with the design, the working system, and also the functionality of our product. Most of them think that the feature that shows the user the nearest tire workshop if the condition of their tire require replacement, and the feature that provide them the nearest towing service would be convenient for them. Also, most of the respondents rated our product as high value for money, so it shows that they would likely to purchase our product.
Last but not least is the conclusion. First, an efficient system that detects the depth of tire tread is successfully developed. The system provides features that can determine the working condition of the tire and is convenient to use due to the simple design of the user interface. As for recommendation, TTUS could merge with the Tire Pressure Monitoring System or TPMS so that the exact tire pressure value of each tire can be shown and a mobile phone application can be created to send information directly to user for cars that did not have built-in screen and did not want to install one. That's all from us. Thank you.